Hello viewers, welcome to Chemistry with Fatima Khan. Today we are going to learn differential thermal analysis. Differential thermal analysis is a technique in which the temperature between the sample and the reference material is continuously recorded as a function of time or temperature. At particular temperature, the sample will changes its state from solid to liquid. At that stage there is decrease in temperature rather than in the reference. It will goes on increases with the increase in temperature. The difference between the sample and the reference is known to be as differential thermal analysis. This DTA both the test sample and the inert reference material alumina controllable heating and cooling programmable. If the difference is zero between the sample and the reference material, they do not undergo any chemical or physical change. In any reaction take place, the phase transition differential will occur with a small will occurs between the sample and the reference material. Phenomena causing the change in the temperature: adsorption, exothermic process; deabsorption, endothermic, a change in the crystalline structure, endo or exo; crystallization, exo; melting, endothermic; vaporization, endothermic; sublimation, endothermic; chemical, oxidation, exothermic; reduction, endothermic; breaking down of reactions, endo or exo; chemoabsorption, exothermic; solid state reaction, endo or exothermic. This principle of DTA is differential thermal analysis is a technique in which the temperature of the sample or a substance under investigated with a temperature in a thermally inert material. The graph is plotted with a delta T by temperature. If delta T is positive, then it is exothermic, in the sense sample temperature is greater than the reference. If delta T is negative, then endothermic, the sample temperature is less than the reference. Exothermic are crystallization and oxidation, therefore the peaks are above. Melting and decomposition, it's below because the large amount of energy is released. Also from this we get to know if it is sharp endothermic peak, then the reaction is undergoes melting, fusion, transaction from one state to another. If the peak is broad, that to endothermic, then it's a dehydration reaction. If an exothermic peak, which mainly shows the chemical reaction like oxidation reactions. One of the calcium monoxide, here in the presence of air, first H2O water is removed, second CO2, which is an exothermic, and H2O, CO and CO2. CO is an exothermic, it's a exothermic, these both are endothermic. In the presence of air, the reaction is the graph is showing this in the presence of an air. Comparison between thermal analysis and differential thermal analysis. Here in exothermic, in TA graph, the reaction interval will be vertically. It's vertically, but in case of endothermic, the reaction interval is horizontal. Here, horizontal. Therefore, if it is vertically above, if it is horizontal, it is below. In the case of differential thermal analysis. Instrumentation. Sample holder, sample or the reference cell made up of alumina, sensor, platinum, rhodium or calminium, aluminium, thermocouple one for the other. Sample and one of the reference joining to a differential temperature controllable. Furnace, aluminum block containing sample and reference material. Temperature control, control of temperature programmable and furnace atmosphere. Recording system. Factors affecting DTA curve. DTA is dynamically temperature technique, therefore large number of factors can affect. They are divided into two groups, that is instrumentation factor and sample factor. Instrumentation factor: furnace atmosphere, furnace size and shape, sample holding material, sample holding geometry, wise and bed size of thermocouple junction, heating rate, speed and response of recording instrumentation, thermocouple location in furnace. Sample characteristic: particle size, thermal conductivity, heat capacity, packing density, swelling and stinging of sample, amount of sample, effect of dilution, degree of crystallization. It's a case study in which differential thermal analysis, effect of heating rate on peak amplitude compound using the crystal protonated. With the increase in the temperature, the most sharp peak was observed. At 2.5 it was see here, with the increase in the temperature per minute, the most sharper peak and the highly amplitude one which was observed. Furnace atmosphere. There are generally two types. One is static and dynamic. Atmosphere of calcium oxalomonohydrate in the presence of air and in the presence of CO2 environment. In the presence of air, here it is of H2O, this is for CO and this is for CO2. The CO for the air is an exothermic reaction, but in the presence of atmosphere of CO2, it is an endothermic. Elimination of water, CO and CO2, all are endothermic process. But in air, elimination of water and CO2 gives endothermic process, but the elimination of CO gives exothermic. CO will burn in air at the furnace temperature. This is the effect of environment. Sample holder: low thermal conductivity material endothermic, high thermal conductivity material exothermic, made up of premix holder and metal holders. Thermocouple location: effect on having asymmetrical arrangement of sample and the reference thermocouple. It should be placed with a proper distance. Thermocouple placed in 0.06 centimeter from the center of the sample and at 0.3. The distance variation: if it is placed in 0.3, it was observed to be as like this. Here a quite variation, not sharp peak was obtained. Therefore, the position should be placed in a properly. Sample particle size, or this was for the original A. This is for the originally and slightly ground and finally powdered. Finally, with a small particle will obtain a sharp peak. Effect of diluent: masking effect of the sample causes diluent. 8 quinoline diluent are to 6.9 percentage of carbodinium and 8 quinoline diluted to 5.6 with alumina. It should be properly masked. This is for the first one will properly to 6.9 percentage for 5.5. The sharp peak was not at all appear. It appears in different range. Therefore, it is not valid. This is one correct. Factors that influence DTA curve. heating rate, effect, change in the particle size and the position, using of low heating rate, location of thermocouple, irreducibility curve, standardization thermocouple location, atmosphere around the sample, changes the curve, atmosphere of the sample, change in the peak size and the position, particle size of the sample, irreducibility curve, particle density, irreducibility curve, sample container, change in this in the peak. DTA and DTA curve is here relevant to the sample weight, changing due to the sample weight, where here it is because of the phase transaction.